Hi everyone, bonjour. Welcome to my YouTube channel, the IB Crocodile, specialized in providing academic videos for the IB program, Physics and Mathematics. Today, I'm going to continue on solving quadratic inequalities. In a previous video, I showed how to solve quadratic inequality as an important skill that you need to master during your journey in the IB math analysis and approaches. I'm going to leave a link in the subscription for that video, but today I'm going to talk about the why part. Okay, so previously we know, or I showed you how to solve a quadratic inequality, but then today I'm going to talk about applications, right, when we need, to solve a quadratic inequality. So bring your pencils and let's have fun. Okay, so one application of solving quadratic inequalities is to find the domain of certain composite functions. So let's have a look at this example here. Find the domain of the following function, square root of 4x minus x squared. So we can pretty much rewrite this function as a composite or a chained two functions together. So as, let's say, the parent function, I can imagine, f of x is going to be a square root of x, and another function that is chained or, composite with f of x, which is, let's say, g of x, is going to be 4x minus x squared. So if you write f of g of x like f of g of x, right, which means you present the expression of g into f of x, which means you're going to replace each x by this expression. So then you reach this function here. And that is called a composite function. So f of g of x, and in this case, is going to be the square root of 4x minus x squared. Now, to find the domain, now here is writing the technique. So the maximal domain of the composite function y equal f of g of x consists of those values x, because the domain is all values of x, like possible values for x, right, in the domain of g, such that the whole g of x, okay, is in the domain of f, right? So that means the g of x as like inner function has to follow the domain of the parent function or the outer function. While considering any restrictions of the domain of G, I will get back to this in a few minutes, but let us first try to understand, okay, what is the domain of a square root of x, okay? So in order to figure out that, maybe one way we can try to graph and look at the sketch of the square root of x, okay? As IBMAASL, you need to be familiar, or you need to sketch these parent functions, right, by yourself in paper 1 without using graphic calculator. So this is basically how the function looks. So first of all, when you see here, there is no curve, there is no curves on the negative side of x-axis. That means there is no negative values, which makes sense because you cannot put negative under the square root. Otherwise, it will be an imaginary number or complex number, so it's going to be the negative numbers will not be included in the domain. Now, of course, here we see the positive numbers, right, and then 0. So now let us ask ourselves, can I put 0 inside here, like square root of 0? The answer is yes, because root 0 is just 0. Okay. So the domain of square root of x is going to be all positive numbers, including 0. Okay, so let's go back to the question here, right? And we can say, okay, so the domain of root of x, right, is going to be whatever under the square root has to be bigger than or equal to 0, right? So here, what do we have? We have 4x minus x squared, which is g of x, which has to follow the domain of the parent function, In this case, I'm going to say 4x minus x squared is bigger than or equal to 0 to respect or to honor the domain of the square root of x. And here you can see now a quadratic inequality is being created. And that's why, you know, that's why we need to be very good in solving quadratic inequalities. So the step 1 is already here, right? We have the right hand side of the inequality is 0. And then step 2, we're gonna find the critical values or the zeros of this inequality. So 4x minus x squared, let's say, equal to 0, just to find the zeros, right? So what we can do here, we can take x common factor. So what is left here is 4 minus x equals 0. So then x equals 0, or 4 minus x, I mean the second factor, 4 minus x equal to 0 implies x is equal to 4. Okay, so this is the second step to find the zeros of the inequality. Now, the third step is to draw this the number line. Okay, so let's sketch the number line and put the critical values on the number lines. Here, the critical values are just the zeros of the inequality. So we're gonna put here 0 and 4. Now, since we have on the symbol or equal, that means these numbers are included in the solution. Okay, and that's why I draw here a closed circle on the number line for both of them, 0 and 4. Okay, otherwise it would be an open circle. So then what we notice here, the number line is divided into 3 regions, right? So then we need to find the sign of the inequality in each region by picking a testing point. So let's pick a point below 0, -1, for example. So if you put -1 here in this expression here, so -1 to the power of 2 is just 1, and here is going to be -4, so -4 -1 -5. So this section here is going to be a negative section. And then let's pick a value between 0 and 4, let's say 2. So if you put x equal 2 here, so 4 times 2, 8, 8 minus 2 power 2 is 4, so 8 minus 4 is 4, which is positive. I don't care about the result, I care about the sign. And now let's have a value or pick a value bigger than 4 to find the sign in this section. So let's say 10. So 4 times 10 is 40, but then I have 10 squared here is 100. So 40 minus 100, you have a big number on negative side. So obviously also is going to be negative. And this is what we call a sign chart, right, of this expression of this inequality. Now the last step here is to write down the solution interval, right? So here we are looking at what are the values of x. Okay, what is the interval that satisfy this inequality to be bigger than or equal to 0, which is from 0 to 4 inclusive. Okay, so the solution set here, x is going to be between 0 and 4. Now you see here I put the interval as closed interval. Another way to express that, you can tell me, okay, x bigger than or equal to 0, less than or equal to 4. That's fine, whatever works for you. So both of them are correct. So now we can now write down the domain of this function here, because the domain of this square root 4x minus x squared is all the values that satisfy this inequality here, as we discussed. So we can say, okay, so the domain of square root of 4x minus x squared, right, is going to be exactly x, or all x belongs to R, such that x is between 0 and 4. Now the last point to check, okay, you ask yourself, okay, if there are any restrictions of the domain of G. Okay, so in this, if there were any restrictions, you would exclude it from the domain, of course. So now look at G here. G of x is 4x minus x squared, which is a polynomial function. So what is the domain of any polynomial function is the set of real numbers. So that means there is no restrictions on g of x. So that's fine. So that's mean this is our final domain of this composite function. Okay. Let's have a look at another example here. Find the domain of the following function, 1 over square root of 4x minus x squared. Let me call it h of x. Just, let me call it h of x. And now what we are looking here at what we call a quotient function. I cannot call this a rational function. I cannot call it a rational function. Why? Because the rational function is the division between two polynomial functions. But since the denominator here is not polynomial, so I cannot call this a rational function. Okay, so we're gonna deal with this as a division or quotient between two functions. So what are the rules? What is the rule, or how to find the domain of a division of two functions? I will show you. So step one, finding the domain of the numerator. Okay, so let me call, for example, the numerator f of x is a function at the numerator, and let me call the denominator, I don't know, k of x, another function. Okay, so we need to find the domain of 1 or f of x. Now, when you look at f of x equal 1, we can write this as 1 times x to the power of 0, given that anything power 0 is 1. But why I rewrite it as like that? Because I can see this is a polynomial function with 0 degree, right? Which is called the constant function. So once I realized that this is a polynomial function, so the domain of this polynomial function is always the set of real numbers. Okay. Now, step 2, finding the domain of the denominator. So find domain of the denominator, which is the square root of 4x minus x squared. And we already found that in the previous example, right? So the domain was between 0 and 4. So the domain is going to be x belongs to between 0 and 4 in the interval, closed interval. Now, step 3, finding the point or the intersection. So find the intersection domain between these two domains. So in order to do that, allow me to draw a couple of straight lines to visualize the intersection between the two domains. Okay, so the first straight line here for the f of x for the denominator, which is basically the set of real numbers. So basically the domain is everything here on the straight line, on the number line. Now, the second number line is going to be representing the domain of the denominator, which is between 0 and 4. So now you can tell me what is the intersection between these two domains, right? So obviously is going to be this part here is repeated, is common between the two domains or the two straight number lines. Okay, so step 3, the intersection of the two domain is going to be from 0 to 4, x between 0 and 4. Now, step 4, exclude the zeros of the denominator. So step 4, finding the zeros of the denominator. Why is that? Because you cannot divide by 0. Otherwise, it will be undefined quantity, right? So what are the zeros? What are the values that makes the denominator 0, which are the same values that makes this expression 0, which is basically 0 and 4. We found them already. Okay, so the zeros of the denominator right is going to be x. I mean, the zeros is going to be 0 and 4. Okay, so therefore the final domain now of h of x is going to be the intersection excluding the zeros of the denominator. This is the typical approach to find the domain of any quotient function. That means two functions divided by each other. So the domain of h of x is going to be x belongs to R, such that x belongs to from 0 to 4 open interval, because 0 and 4 now are excluded from the domain, right? Or we can write as x is bigger than 0, less than 4. Another example of application of quadratic inequalities, again, the domain of a certain composite function. So what do we have here? We have len of 4x minus x squared. So I could also look at this function here as a composite or a chain of two functions. Why? Because I can say, okay, maybe I have a parent function is len x, like len something, so len x probably the parent function, and g of x is whatever the inside, so, or the inner function for x minus x squared, right? So then if you like to say, okay, what is f of g of x as a composite, is going to be g into f. G into f, meaning you're gonna replace each x by the expression of g. So it's going to be len of 4x minus x squared, and this is what we need to find the domain for. So in order to do that, we can also investigate the graph of len x, the parent function. So let's have a look at this graph here. And again, you need to actually know this graph by heart in MAA, SL, or HL. Just the parent function, and then you can maybe the question can ask for some transformations, but at least you need to know the parent functions by heart, like len x, x squared, 1 over x, y equal x, and all of this, and so on. So let's have a look. So first of all, we have here, like if I zoom in, right, actually this graph does not touch the y-axis. The graph does not touch the y-axis, which means 0 cannot be in the domain, while all the values of x lie on the positive side of the x-axis, which means what? Which means the domain of len x is x bigger than 0, period. So the domain of len x is x bigger than 0. X cannot be 0, and x cannot be negative. So again, I am forming inequality. So by saying this, I already formed an inequality. So to find the domain of len 4x minus x squared implies whatever inside the len, right, has to be bigger than 0. So let's now build an inequality. So 4x minus x squared has to be bigger than 0, right? And then you can follow the steps to solve the quadratic inequality. It was exactly the same inequality here. We solve it there, but instead of bigger than or equal, we have now bigger than, which means the solution set is going to be between 0 and 4, excluding 0 and 4, right? So I know the answer already. So the answer here is the domain is going to be x belongs to the interval. Now the interval here has to be open interval, right? Because 0 and 4 are excluded. And the last point to check if there are any restrictions on g of x. Again, g of x is a polynomial function, which means the domain is the set of real numbers for g. So that means this is the final domain. I don't need to exclude or avoid any restrictions, for g, and that will be our domain for that composite function. So by this, I conclude my video for today. Please leave any comments or likes, and have a good day.